In today's lesson, we are going to be looking at solving equations with brackets. Now, we've kind of covered this already in the first lesson of this unit, but we're going to look at it a little bit more in depth and look at a few more examples. And this is going to require some knowledge of distributive property, which we covered in the previous unit. So if you don't quite remember that, please make sure you're going back and checking those lessons before you start this one. Before we get into the actual lesson, though, we are going to do a little bit of a warm up to get us kind of familiar or get us thinking about the topic. So, Gabriel and Kayla each received the same set of tiles. They arranged them differently and they also wrote different expressions to represent their tiles. What expression do you think Gabriel might have written, and what expression do you think Kayla might have written? So, we can see the two sets of tiles here and how they arrange them. So, if we look at Gabriel, how do we think they might have written the expression? Well, by looking at it, they seem to have grouped the x's together and the 1's together. So let's do the same thing when we write our expression. How many x's do they have? Well, they have 3 x's. So let's start with that. They also then have 6 1's, and they're grouped together. So we can have 3x plus 6. So that could be what Gabriel had written down for their expression. What about Kayla? Kayla's done it a little bit differently. They've grouped an x and 2 1's together. And they've done that 3 times. So we might say x plus 2 plus x plus 2 plus x plus 2. Is there another way that we could rewrite that, though? Obviously, we could collect all the like terms, but if you still want to represent how Kayla has arranged the tiles, how could we represent that if I have 3 groups of the same thing? Well, you might think, well, 3 groups of the same thing, oh, that's exponents. Not quite. Remember, exponents means we're multiplying the same thing. Here, we're adding the same thing. So when we're adding the same thing, we multiply. So I could do 3 times x plus 2. I have 3 groups of x plus 2, which we can see in Kayla's representation. So this would be how she might have written the expression. So these two expressions mean the same thing. So try to think about what would we do to calculate or to write each expression the same way. What would we have to do so that it works out like that? What calculations? Looking at another example, we want to create an expression to represent the left side of our mobile or our balance. So if I look at the left side, well, I have 4 x's and 6, so 4x plus 6, 4 unknowns plus 6. Now, what would we have to put on the other side of the balance to make it equal? Keeping in mind that our other balance is then split up into 2. So our other side has a mini balance of its own. So I need to have the same thing on both sides, or in other words, I need to take this 4x plus 6 and divide it evenly. So that could be x, 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 3, and 3. So I've just taken my left side, divided it evenly into 2 for my right side. So that expression would be, well, I have 2 groups of the same thing, so 2 times 2x plus 3, which we see visually. So now, which of these expressions do you think would be easier to work with if we had to solve for x? Would you rather work with the 4x plus 6 or the 2 times 2x plus 3? Now, there may be some reasons for either or, but most people, or I might think most people might choose the first one, the 4x plus 6. Even though the numbers are larger, it is only a 2-step equation now, and we've worked quite extensively with 2-step equations. We've come back to them in the multi-step equations lesson, and we started with them in the 1 and 2-step equations. So we should be fairly comfortable with 2-step equations. So we might, or I might suggest that we work with the first one, the 4x plus 6, rather than the 2 times 2x plus 3. Again, your choice may be different, as long as you have a reason why, and as long as you are able to go through and solve it. But what we're going to look at today is solving those equations with brackets. So if we have an equation with brackets, what we want to do, we need to expand the brackets first, and then collect any like terms, or hopefully our equation is a little bit easier to solve. So expand the brackets first. This should be familiar because this is what the distributive property is. So we learned the distributive property previously, right? And that was basically the number outside the bracket multiplies everything inside the bracket. We have two groups of 3x minus 5, so we have two groups of 3x, and we have two groups of minus 5. So that 2 multiplies to both parts. So in this case, 2 times 3x is 6x, 2 times minus 5 is negative 10, and the 14 just stays the same. It's not a part of the bracket, so we don't multiply it by 2, and it's not even on the same side of the equal sign. Now that we've expanded or used the distributive property, we now have a two-step equation. So we want to cancel out the minus 10 by doing the opposite, or add 10. Balance the equation by doing the same thing to both sides. One side will cancel out. We have 6x equals 24. Now we're down to a one-step equation. You might be able to just look at the equation now and figure out what x equals. If not, we have to divide by 6 on both sides. The reason we're dividing by 6 is because the 6 is technically multiplying the x. So I have 6 groups of x, or 6 times x. To cancel that out, I do the opposite, which is divide by 6. So the one side cancels out, and we're left with x equals 4. And that's my solution. That's my answer to the equation. Next example, 6 times 3k plus 5 equals 49. So I have brackets, so I'm going to do the same thing. Distribute the property, multiply that 6 through to both parts to get rid of the brackets. Of 18k plus 30 equals 49. Now I have a two-step equation. I want to get rid of this constant, this separate term, this plus 30. I'm going to subtract 30 from both sides. One side will cancel out. I'm left with 18k equals 19. Now, it doesn't quite work out to a nice number, but let's continue through our next step. Right? So this is helpful if we don't end up with a nice answer. We can't just plug in a value. So we want to divide by 18 on both sides. One side will cancel out, and we're left with k is equal to, and I'm just going to leave it as the fraction, 19 over 18. You could divide those two and get an actual value, be 1 point something. I'm just going to leave it as the fraction. The next one is the same idea, even though we have two sets of brackets now. The two sets of brackets are on opposite sides of the equal sign. Not that that really matters when using the distributive property, because again, we're only focused on the number and the terms inside the bracket. So the 5 is going to multiply the x and the negative 2. The 3 is only going to multiply the x in its bracket and the positive 4. So 5 times x is 5x. 5 times negative 2 is negative 10. And that's going to equal 3 times x, or 3x, plus 3 times 4, which is 12. Now we're down to a multi-step equation. And we're at a multi-step equation because I have variable terms on both sides. I have the 3x on one side, I have the 5x on the other. So the First step with a multi-step equation is to cancel out the variables on one side. Again, we mentioned the rule of thumb is to get rid of the smaller variable. So in this case, the 3x, only because this will help make it easier. We'll be dealing with less negatives as we work through it. Not that it matters though. You could get rid of the 5x if you wanted to or cancel it out. Either way will work in the end. So minus 3x from one side, minus 3x from the other side. Again, remember I'm deliberate on where I put that minus 3x because you can only subtract from like terms. So I can't subtract a 3x from a 10 because it's not like terms, but I can subtract it from the 5x because they are like terms. We now have 2x minus 10 is equal to 12. And now I'm down to a two-step equation. Add 10 to both sides. One side cancels out. 2x is equal to 22. Last step, you might be able to just jump right to the answer. If not, you're going to divide both sides by 2. One side will cancel out, and x is equal to 11. So if we have brackets, we could end up, once we distribute the property, with a multi-step equation. So when we distribute the property, we might end up with any of the previous types of equations that we found. And again, that's what I kind of mentioned in class earlier. We're just adding some complexities to these equations, but by just using one or two small steps, we break it down into simpler and simpler forms, right? So we go from brackets to a multi-step, to then a two-step, to then a one-step. So we're going through that kind of progression, making it an easier and easier equation until we finally get our answer. So it is a lot of repeat of the different forms. Next example is again a little bit is just adding some more complexities, but just adding some more terms. So the 2 we need to multiply to just the bracket it's attached to. So the 5c and the 2c, or sorry, the 5c and the 2, the minus 2c that we see here doesn't get multiplied by anything because it's not inside the bracket. On the other side, the 3 multiplies the 2c and the 3. Again, it doesn't touch the 7 because it's not in the bracket. 10c plus 4 minus 2c equals 6c plus 9 plus 7. Now that we've done that, you might say, oh, it's a multi-step equation. I see the variables, the 6 and the 10c on both sides, and you would be correct. However, there is something we can do beforehand. We can collect like terms. So on the left side, I have two terms that have a c. And on the right side, I have two terms that are just numbers. So I can collect those to make it easier on myself when I go through and start to solve. So 10c minus 2c is 8c plus 4 equals 6c plus 16. Now we're down to a a multi-step. Right? We have c's on both sides. I'm going to subtract or get rid of the smaller one. I'm going to minus 6c, minus 6c. One side will cancel out. 2c plus 4 equals 16. Now I'm down to a two-step equation. Get rid of that separate term. Opposite of plus 4 is minus 4. Do that to both sides. One side cancels out. 2c equals 12. And the last step, if you need to, you could just jump right to the answer. Otherwise, we divide both sides by 2. One side cancels out. And we're left with c is equal to 6. And again, we do know how to verify our answers. We could take this answer and plug it back into the equation. Now that we're multiplying, we're going to look at some area questions that come into play because area deals with multiplication. So we might see some brackets when we're dealing with area problems and equations. So just in general, how would you express the area of a rectangle? Well, the area of a rectangle is length times width. Perimeter, we could do perimeter is equal to, you could say length plus width plus width. Or what you could do, you could say the perimeter is equal to 2 times the length plus the width. Let me just write this in cursive just so we don't confuse it with a 1. So we could do 2 times the length plus the width. So using those previous expressions, let's plug these new values in. So we had perimeter is equal to 2 times the length plus the width, and we had area is equal to length times width. So perimeter will now equal 2 times 6 plus 5x minus 4, and the area will equal 6 times 5x minus 4. Now, it doesn't really matter which is length and which is width. Right? With a rectangle, we could rotate it and just change the two, but it is easier when we have just the single term or the 6 as the number that's in front of the multiple term or the binomial or the 5x minus 4. So these are our two new expressions now that we have actual values. So now that we have actual areas and perimeters, let's use our expression that we just created to create an equation now and then solve for x. So with area, we know area is equal to length times width. We now know that area is 66 centimeters squared. Our length was 6, and our width was 5x minus 4. So let's go through and solve this now. So we take the 6, we multiply it to both parts. We get 66 is equal to 30x minus 24. We want to cancel out the minus 24, so we're going to add 24 to both sides. Oops, not 42, 24. One side cancels out. We have 90 is equal to 30x. You could figure out or just jump right to the answer. If not, divide both sides by 30. One side cancels out, and we have x is equal to 3, or 3 is equal to x. So using the area equation and the known area, we've now solved for x. We're going to do the same thing, except we're going to solve for x using the perimeter. So that was p equals 2 times the length plus the width. So in this case, 2 times 6 plus 5x minus 4. And we do know that the perimeter is 34 centimeters. So let's go through and start to solve this. We might say, well, I'm going to multiply my 2 through to my bracket. However, I'm going to do one step first. I'm going to simplify it and collect like terms, the 6 and the minus 4. So 34 equals 2 times 6 minus 4 is 2 plus the 5x. Now I can work through my brackets. So that 2 is going to multiply through to both parts. So 34 equals 4 plus 10x. Now I'm down to a two-step equation. I'm going to minus 4 from both sides. One side will cancel out. I have 30 equals 10x. You could jump right to the answer if you are good with your times tables. If not, we divide both sides by 10. One side cancels out, and we're left with x equals 3. So does that make sense? what do you notice? Well, what we should notice when working through that is that both equations gave x equals 3. So both equations gave us the same value for x. Does that make sense? It should, right? If it's the same rectangle, so unless the perimeter or the area was wrong, we should have the same value for x, because by plugging those values for x in means we have only one set of dimensions, which should make sense for a rectangle. So in this, now the last step, we want to figure out what is the length of the rectangle and what is the width. Well, the length is 6. There's no x there. We don't have to plug anything in. We know it's 6. The width, on the other hand, the width is equal to 5x minus 4. But we know now that x equals 3. So we can take that value and plug it in. So 5 times 3 minus 4, 15 minus 4, or 9. So we now know that our width is 9. If we want to include our units, we would say 9 centimeters. So we can figure out the actual dimensions by taking the value for x that we found and plugging it back into the equation, or into the expression for the side length, and solving. One last thing we're going to look at. We're going to look at another method. So we're going all the way back to the first equation that we solved for in the beginning of this lesson. 2 times 3x minus 5 equals 14. So on the left side, we see using the distributive property, which is the steps that we went through to solve. Right, so we multiplied this 2 through to both parts. Then we moved things to the other side, or we canceled things out. Right, we added a 10, we added 10, then we divided by 6 on both sides, and we got an answer of x equals 4. Is there another way that we could have solved this? Is there something that we could have done instead? And I'll give you a hint. It has to do with the very first thing we did. So the very first thing we did was multiply. We multiplied that 2 through. But let's think back to our opposite operations. If I'm multiplying, can I cancel that out? Can I get rid of that somehow? So if I'm multiplying everything here by 2, can I cancel that out? Can I just divide this entire side by 2? Would that cancel out the multiplying by 2? And it would. Because if I'm multiplying by 2 and then dividing by 2, opposite operations, they cancel each other out. But I need to keep things balanced. So I'm going to divide by 2 on the right side as well. So by dividing by 2 on both sides, that gets rid of that 2 that I'm multiplying by. So that removes those brackets. So now I have 3x minus 5 is equal to 7. Let's see if we get the same answer now. Let's go through and solve. This is just a two-step equation. I'm going to add 5 to both sides, opposite. The one side will cancel out. We have 3x equals 12. You could jump right to the answer. If not, divide both sides by 3. One side cancels out. X equals 4. So we get the same answer. So the second method that we could be using, or the other method that we could use, is we cancel the multiplying first. I'll just put opposite operations. So we could cancel out that multiplying first. We could cancel it out by dividing or using opposite operations. and we would go through and we would get our same answer. Now you want to be careful because this is only specific to certain cases. One, it should look something similar to this, where we just have a value on one side. If we have one of the multi-step equations with brackets on both sides, it's not as simple and it's not an easier method. So this really only works when we have just a value on one side, and it needs to be divisible by the value that I'm multiplying. So this 14 and this 2, 14 can be divided by 2. So that makes it work. But let's say it was a 3. 3 times 3x minus 15, or minus 5. Let me just write that down here. 3 times 3x minus 5 equals 14, just as a hypothetical. If I was to cancel this 3 out, divide by 3, divide by 3, the one side still cancels out. 3x minus 5 equals, 14 divided by 3. That's going to give me a decimal number, right? Or if we leave it as a fraction, I don't like fractions. So you want to make sure that the number that you're multiplying by, so this value in the bracket, divides nicely into the number on the other side. So even though this is another method that will work, it's only easier than distributing in certain cases. So you want to be careful of that. But if you recognize the scenarios where it does work, then by all means you can use either method. And that's it for solving equations with brackets. So again, we've covered distributive property before. We've looked at these scenarios in previous lessons. So make sure you go back and look at the simpler examples first before, or if you have trouble with some of these ones or understanding these ones. So again, make sure you're kind of understanding the basics before you kind of move into these more complex ones. Again, just dealing with more and more complex equations, but just using one or two steps to break it down into something simpler that we've seen quite a bit of.